So the Design, Build and Fly competition is run by the AIAA in the US.
It's where you get a bunch of competition constraints and you have to build the best model plane to those constraints.
Students can apply their skills and theory into applicable situations, designing model aircraft and competing in different missions.
It's in the name, design, build and fly a model aircraft. This could be anything from something this big to a 2 or even 3 metre wingspan, depending on the competition rules for that year. The rules change each year. The team has to meet some specific criteria. This could be achieving an acrobatic feat, flying a particular payload, taking off in a really short distance. We don't know what it's going to be until the rules come out.
So the current aircraft was designed to meet a number of specifications. The first one was that the aircraft had to fit in a box of 62 linear inches, that is its height plus its width and its depth. In that box, it needed to carry the fuselage, 2 sets of wings, and all of the payloads that it could possibly require.
We were actually one of the larger aircraft at the 2022-23 competition. It has a wingspan of about 1.8 metres, it's about 1.6 metres in length. The aircraft itself can easily fly 60 or 70 kilometres an hour. These things are frightening actually. It's 10, so you got 6 or 7 kilos flying at a 60, 70 or even 80 kilometres an hour. And they can get quite close while they're doing that, so they're definitely beasts. For the next year though, I don't know what it will be. I'm really excited to see what the team comes up with. Based on the new rules, actually I expect a smaller aircraft may be more competitive, something that can go at 100, 120 kilometres an hour and just whip through the laps. So that'd be really cool to see.
It was a very challenging, complicated project. It was hard to get the design exactly right so that there were no post-manufacturing revisions needed. We worked really hard to build and get the aircraft together to try and test equipment and structures, but a lot of it was unknown.
About 3 weeks before the competition, our aircraft crashed. We were flying it down at Victoria Park and the tail wasn't glued on quite right and just flipped 90 degrees in the middle of a flight, and then we have this beautiful video of it just coming down and crashing into a million pieces.
Oh! Ah!
And I kind of knew it would happen. We designed that aircraft to be a prototype, and we knew we were going to have to rebuild it, but not quite that close to the competition date. So we had about 3 weeks of very long nights going to the workshop and building the entire aircraft again from scratch and learning from the mistakes that we made with the first prototype, which is all part of the fun. And then the real fun really began when we got to the competition. When things go wrong, you sort of just got to get creative, and that's really a lot of the fun. So we had switches that broke and we had to repair them 5 minutes before our test inspection. We had to do our first ever test flight of this new aircraft in the US with not much sleep and in a place we'd never been before at Tucson, Arizona. I think it was about 25 kilometre-hour winds, which for a model aircraft is a lot. And it flew beautifully. For the second mission, the requirement was to fly as many laps as you could in 10 minutes. We had an estimate of how many laps we could fly. We knew how long it took for us to do a single lap.
We had never flown the aircraft at the takeoff weight that we had used. We calculated the amount of thrust and lift that the aircraft would require at what you'd call a hot and high environment, where the air is a bit thinner than you would normally expect, and that reduces the aircraft performance. But the conditions were even worse. There were strong crosswinds and the aircraft was heavier than we had planned. And it required a lot more power to fly than we had accounted for. So I was turning broadly, quite conservatively. I was trying not to load the aircraft up too much. because we'd seen other teams crash during this mission and destroy their aircraft by pushing it too hard. That meant that our laps were a fair bit slower and we were using more power for each lap. The aircraft was supposed to go for about 10 minutes with reserve, but at about the 8-minute mark, I noticed that the tone of the aircraft, the sound it was making, was starting to lower in pitch, meaning that the propeller is starting to slow down.
Yeah, so we just kept flying and we got to about 9.5 minutes and we were getting ready to finish our final lap. And I was the observer. Greg, our pilot, was the pilot. And as the observer's role, you have to just be quiet and only tell the pilot what he needs to know, what they need to know, and don't freak out when something goes wrong. And we get to the 9.5 minute mark and the aircraft just loses all of its power because we completely used up the entire battery. We didn't know it was going to do this, and we're way up in the air, ages away, and Greg has to go and land the aircraft. And
so I said, "We're dead," and Harry promptly panicked and went, "What?" And I was like, "Let's just get out of the way." And backed off slowly, and
I asked Greg, "Can you land the aircraft?" And he says, "I'm gonna try."
If the mission was to count, I had to land it on the runway, and I was about 100 feet west of the runway and heading in the wrong direction.
This is the second mission. We still had to do the third mission, and we could lose the aircraft at this point, and we'd lose that second mission as well. We'd basically lose the competition.
So I needed to make a fairly complicated S-turn to bring it back. So I made a 180-degree turn. I had to keep the nose low so that we didn't slow down and stall, because I was still quite worried that the aircraft is very heavy.
And Greg, being the amazing pilot that he is, just brings it in for a loop, and because it's got nice characteristics, it just glides down to a nice landing.
The aircraft did land on the runway, which was the first thing we needed for a completed mission. It was moving sideways a little bit, so it hopped and skipped on the wheels and bounced, but it did manage to settle down and stay on the runway and just start rolling normally. And that meant that we completed the mission. That gave us a valid mission. And the aircraft promptly then rolled off the other end of the runway into the weeds.
It's a long landing because it doesn't have power, but it was great. And the fact that we were able to stay calm and collected and just do what we had to do meant that the people running the competition, the people scoring us, didn't even know it ran out of power.
Yep, so currently we're working on redesigning the last year's competition plane, where we just designed some winglets out of 3D printing. We chose to improve the plane by doing winglets, as it will reduce the tip vortices. So we chose the winglets and wingtips so we can compare wingtips just rounding off the edge and then the winglets and see how it improves the plane and its aerodynamics.
One of the highlights for the DBF so far has been seeing the plane in action, just really getting a grasp for how the engineering really comes to life and seeing the effects that certain design changes have on the plane.
Rather than having the horizontal stabilizer with little control surface.
Biggest highlight for me in the competition so far has been learning Inventor and learning a bit of CAD, being able to apply changing parameters into a CAD, and it's pretty interesting, and something outside of theory which we learn in uni.
We joined the Design Build Fly competition to get some more hands-on training and to develop our experiences and knowledge for future.
There's a lot to be learned from a competition like this. So I've been exposed to what the industry is doing and what they want as a part of seeking sponsorship for this competition, and as a part of expanding what the students are doing into their capabilities. We've been speaking with industry members, been speaking with with government members, and we've been exposed to this new wave of UAV development that is happening in Australia. It's going to be happening really soon, and this is something that we can leverage.
I think the practical experience learning CAD and stuff is definitely something which has taken me further in my studies. Being able to actually apply that to some of the theory that we do and the projects that we do specifically space vehicle design. Also learning some more soft skills in like team management is definitely something which has been applicable.
I joined the DBF because I wanted to expand my aerospace knowledge. I'm planning on majoring in aerospace and wanted to get a lot of hands-on action, get understanding how planes work. Is easy in the classroom, well, kind of, but it'd be better to get hands-on experience and actually make a plane.
The reason we were successful last year is because we were a small group of passionate people that wanted to see this thing happen for the first time, to prove that not only could we do it, but the university could do it. And this year, yes, it's a larger group, but I don't think it has any less passion, any less drive than we did last year. In fact, I think it has more. So I have no doubt that they can succeed.